part of configuration files and important properties, so far we have seen how to review the properties from both command prompt as well as Cloudera Manager, and then we actually get into the details with respect to important yarn properties. Now let's discuss about important Mapreduce properties. So the file which contain Mapreduce properties is nothing but mapreduce.xml. As yarn and Mapreduce are tightly coupled as part of Hadoop ecosystem, you will be able to see the properties from the same location in the Cloudera Manager. If you click on the yarn service and then go to configuration, this actually gives us the properties not only related to yarn but also Mapreduce. That's why you can see yarn MR2 included. Okay. Now let's start with the most important property with respect to Mapreduce, which is nothing but Mapreduce framework name. The purpose of this property is Mapreduce is a processing engine, whereas yarn is a resource management service or framework. In future, if there are better alternatives than yarn, Mapreduce should be able to plug into it, and that's why they have defined this property called Mapreduce framework name. We need to set this property. By default, when we set up the cluster, it is taken care of automatically for us, and it should be yarn. There is another framework also which is local. Typically, when you have a single node cluster, it will be running in local mode. That being said, the next important property is the web app address for the job history. So as you submit the Mapreduce jobs, you might want to see the history of those jobs, and those are provided as part of the IP address and port number. In our case, it is nothing but Big Data Server 4. As the STL is still on, we can actually go here into the Cloudera Manager and expand the web UI, and you can actually click on History Server Web UI. It will take you to the Mapreduce job history server. Here you should be able to go through the completed Mapreduce jobs or killed Mapreduce jobs which are submitted earlier, and you should be able to troubleshoot if there are any issues with respect to those jobs. You can see the details here. Earlier we have submitted 5 jobs for different purposes, and you can see all those details here. Because of the job history server only, we are able to see this. Otherwise, we will not be able to see the details with respect to jobs that are completed in the past. Now let us talk about properties related to application master. For each and every Mapreduce job that is submitted using Mapreduce 2 framework, there will be an application master associated with it, and that will take care of the life cycle of that job. Let's actually take this and go to the configuration of the yarn in Cloudera Manager, and let's paste this. Here I have star at the end, which means there are multiple properties which are related to application master, and I just want to review all those properties in one shot. That's why I copied only till this point and pasted here, and it showed 5 properties here. You can actually explore these things at a later point in time. The most important properties are with respect to the capacity of the application master. In this case, the capacity with respect to memory is 1 GB, and the capacity with respect to vCores is 1. And we can actually specify the values that are in the range of minimum and maximum allocation of containers as part of yarn configuration. In this case, when it comes to memory, the minimum memory can be allocated for each container is 1 GB, and maximum memory that can be allocated for each container is 2 GB in our cluster. And then minimum number of vCores is 1 and max number of vCores is 2. So we can actually specify the values within the range of 1 and 2 with respect to both memory as well as CPUs. However, when it comes to CPUs, you cannot pass values like 1.5, 1.25, etc. You have to specify only 1 or 2. Whereas with respect to memory, you can pass any value between 1 and 2 GB. Keep in mind that application master doesn't process the data. It will only keep track of the job lifecycle once the job is submitted. Before actually processing the data, first it will create this application master so that it can take care of the job lifecycle. Now let us talk about the properties with respect to map tasks and reduce tasks. As these are the ones which actually process the data, it is very important for both administrators as well as developers to have decent understanding with respect to the capacity settings of map tasks and reduce tasks. First, let us understand that a map task or a reduce task is nothing but a container from yarn perspective, and hence the capacity settings with respect to map tasks and reduce tasks are inherited from yarn settings. So when it comes to yarn, the minimum allocation MB for each container is 1 GB and maximum is 2 GB in our cluster, even though default is 8 GB. Similarly, when it comes to minimum allocation vCores, it is 1 and max is 2. So the vCores can be between 1 and 2, and memory can be between 1 and 2 GB with respect to each container. Same applies with respect to map as well as reduce, because map and reduce tasks are nothing but containers from yarn perspective. Okay, so that being said, when it comes to the properties related to map and reduce tasks, these Java OPTs are nothing but properties which actually control the behavior of JVM. However, we will not be touching these that often, and hence you can defer them for now. Now, if you talk about the capacity of map, they are primarily controlled by these two properties. One is Mapreduce map memory MB, and the other one is Mapreduce map CPU vCores. If you search for these properties by going to Cloudera Manager, memory is 1 GB or 0 GB, but it actually inherits from the container minimum allocation. When it comes to vCores, CPU vCores. When it comes to CPU vCores, it is 1, but you can give 2 if you want, because our container range is between 1 and 2. The reason why it is actually showing as 0 with respect to map is it will inherit from the yarn, and also if you want to override at runtime, you can actually override by specifying -d, which we'll be seeing very soon. That being said, same thing applies with reduce. The memory setting for the reduce is nothing but 0, and the CPU vCores is nothing but, or vCores is nothing but 1. Okay. Typically, as part of map task, we read data from file system. We apply row level transformations and pass the output to the reduce tasks. Reduce tasks take this map output as input and apply transformations such as aggregations, joins, etc., and save the final output again back to the file system. As the nature of logic that is being executed by map tasks and reduce tasks are significantly different, they have separated the properties related to map tasks and reduce tasks so that developers have the flexibility to use different settings for different type of tasks. That being said, now let us also talk about this property called Mapreduce input file input format split min size. By default, the number of map tasks are determined by the number of blocks of the underlying files. If there are 10 blocks, there will be 10 tasks. If there are 20 blocks, there will be 20 tasks. Let's take an example here. If you have a 2 GB data set and if you want to process, and if the block size is 128 MB, there will be 16 blocks in the file system. As there are 16 blocks in the file system, by default it uses 16 map tasks to read the data and process. However, if you want to override, you can override by setting this split min size. If you set 256 MB, instead of using 16 map tasks to process the data, it will only use 8 map tasks to process the data. So that is the relevance of this argument, and we will see that in action in a moment. So these are some of the important properties which you need to be familiar with respect to Mapreduce. As administrators, it is also very important for the developers. So far we have started with high level overview about files and properties, and then we reviewed important and properties and Mapreduce properties. Now let us run some jobs and see how the changes which we have made over this time will be impacting the behavior of our jobs.